Welcome to Section 3, Video 6, Creating the Player's HUD, Part 1, Basic Setup with UMG Widgets. In this video we are going to set up our HUD class and set up our widgets code. First we are going to set up our HUD class. Let's go into our UI folder in our C++ classes and open up our generic HUD. Here we are declaring our constructor for this actor, and then we are creating our getter functions for our variables within the protected category. We declare 3 variables, which are class references that can only inherit from the user widget class, which is what we will be using to visibly edit and show off our UI. Back to our functions, we declared a function to show a specific menu, which inputs a subclass of user widget, and then we have to set our forward declarations in the parameters of user widget by including the keyword class. Then we are inputting a boolean to check if this is UI only mode of gameplay or if we are using game only gameplay, which means we only want to receive input from our player controller when this is true, and when it is false we don't want to receive any button presses at all. And our final boolean is being inputted in for if we want to show the mouse cursor on screen if it's true, and if it's false we just don't show it. We have this function returning a boolean because we want to know whether or not we succeeded with showing our UI element to the screen. Then we have another function which handles removing all UI elements from the screen. Let's add our definitions. For our constructor we will have to copy and paste it and hand make it instead of automatically creating it using Visual Studio. In our libraries, we will have to include the UI / since our path to our header file is not correct. Save all, and Visual Studio will compile these libraries back into our source file, thus removing our errors. Here we are setting our variables to null, but since they aren't pointers but they do require references to a class, we are going to use the generic C++ null value instead. In our function showSpecificMenu, first we are checking to clear all UI elements from the screen, and then we are checking if class to show is valid. Then we create our widget and save that created widget as a temporary variable so that we can add it to the screen. We are then checking if game only is true. If it is, then we set our player controller's input mode to game only by inputting a construct by calling the constructor function for that struct. This is why we have constructors be in the public category, so that we can create one and also have the default values set automatically. If game only is false, then we declare a struct for our input mode, being UI only. Also, when a struct is declared, even as a temporary variable, it will automatically call the constructor for that struct. Then we are telling the input mode to not lock the mouse within the viewport, so in case we need to click out of the screen or to another window, we can. Then we confirm and update our input mode for our player controller, and finally show our mouse cursor depending on what the inputted show mouse boolean is, and then we return true, meaning we leave the function and return true so that way we know we successfully created our UI. If we return false, that means the class we inputted was invalid, which would be the only reason to fail. Here we are calling an already established function from a function library to remove all widgets from the screen. We use this function in this class because we just include the generic HUD's class header file, then we can just access the other functions as well, including this one, and any getters or setters. Now that we've finished with our generic HUD class, we can actually open up our widget gameplay files by going into our Solution Explorer and double-clicking on widgetgameplay.h for the header file and widgetgameplay.cpp for our source file. Let's fix our path to the header file inside of the gameplay's source file by adding UI /. In our header file, we are creating a pure but not constant functions for getting the current health and ammo values from our player character under the protected category. This is so we can connect UI elements to these functions and it will automatically fire those functions constantly as a sort of binding. Let's add our definitions. Now in our source file, let's add some libraries. Here we are adding our libraries that we will be using within this source file, which will be our player and the text file for returning our ftext struct. Here we are getting access to our player class that owns this widget, and then saving that player class that we tried to get from our owning player pawn, which casting will check to see if we find any sort of code that involves the A player character in terms of inheritance of this pawn, and then we save it as a temporary variable, and we put it within an if statement to see if it successfully did this or not. Another way you could have done this is by putting all of this in one line above it and then checking if player is valid in the next line. But this is cleaner and allows us to organize our code easily. Then we are getting the current and max health values and dividing them for a value between 0 and 1, and then clamping that value just in case so it can't be out of the range of 0 and the value of 1 as our min and max values. And then returning that value as our float value, but if the cast failed, then we would return 0.5 as a backup. Here in getCurrentAmmo, we are doing the same thing that we did with current health, but just using the flat getCurrentAmmo and using the ftext automated function where it uses as number, it converts the integer that is inputted and converts it to an ftext variable in which we can return that. In case the cast failed, we just return a value of 999, just to let us know that we did not successfully cast. Let's build, rebuild, and our project file. In the next video, we will be creating the player's HUD Part 2, building the widget blueprint.